tell us about your time working for CERN.
Well, CERN was probably my most exciting period of my career. CERN stands for, in French anyway, the European Centre for Nuclear Research in Geneva. And it was formed in '54 and brought together all the brightest minds in mathematics, physics and engineering across Europe. But now it's an international, truly international organization, including the United States. I think its mission statement is something like to find out what the universe is made of and how it works. So when you go to work each day with that on the back of your mind, it's actually quite an exciting thing to be doing. I'm an engineer, not a physicist, but our job was to try and construct the zaniest experiments that scientists wanted to do, but of course in materials, so you have to make them real. So it was quite a challenge. My very first job was investigating what's called nuclear magnetic resonance. If you subject molecules to a constant magnetic field and overlay an undulating magnetic field, the molecules can get excited and emit light. And this developed into the MRI. So it's magnetic resonance imaging this time. We also devised the PET scan, which is antimatter and electrons fired together into the body, which produces, when they annihilate each other, they produce light as well. And that becomes the PET scan. So there are lots of useful things that came out of CERN as well, not least of all, the World Wide Web, of course. Although Berners-Lee patented it, it was when he was working at CERN and wanted to correspond easily with other people across the site, it's a very large site, that he devised this system, which we now all use, of course. Things like antimatter, we created antimatter, and another job I had was to find a way of building a machine that would create antimatter and transfer it around the site where we could do experiments. Quite often this is done underground because of the radiation that comes off. So many of the machines, and this is the irony, I think, of particle physics, although it's looking into the smallest things in the universe, the atom, it requires man's largest machines ever made. And I've got here, for example, a poster showing CERN. Can you see that?
Yes, yes.
That big ring is 27 kilometers in circumference. And we would inject particles, parts of atoms, parts of the nucleus, almost at the speed of light around that track, and made them collide and break each other up to find out what bits were in there.